this is interesting. Oh, fascinating. Okay, I think this is enough to get us past the error. But the point is, right, when you have a bug in your code, that's because your code is doing something that you don't expect it to do, right? Like, because you thought your code was working and it's not working. And so now your job is to figure out, why is reality different from your picture in your head? But you might not even know what your picture in your head is. So it's really useful to think about, like, what is it that I think this code is supposed to be doing? Because if I don't know what this code is supposed to be doing, then how am I supposed to figure out, like where reality mismatches my expectation? It's gotten back to us. Look, this error message is different, right? So by inserting the print, we have changed what our program does. So let's scroll up a bit. So I'm noticing something kind of interesting here. So one thing that's kind of interesting is that in the original program, we returned a torch.size object, but inside the torchdynamo region, we're returning a normal tuple. That's bad. We shouldn't do that. So I'm going to file a bug in Dynamo about this. Yeah, I don't know if this actually is causing the problem, but like it's definitely not good. Dynamo is not accurately tracking what is it? When you call, what did we do? We did a size call. I think we did a size call. When you call tensor.size, Dynamo returns a tuple instead of a torch.size. So if I was being nice, what I should do in this situation is I should come up with a minimal repro. But since we're doing a live stream and I don't want to spend too much time making the minimal repro because it's not for the actual problem in question, I'm just gonna give a crappy repro and sucks to be the bug reader. You're gonna have to figure it out instead. So okay. I have this fragment of code based off of the bug report here. This is me complaining about the backtrace not being accurate. So it's the same repro instructions. What I have done is inserted the print. When I run the model, normally this print says torch size. However, when it's run under Dynamo, I don't get a torch size. This is unexpected and can lead to behavior divergence. Now, torch.size is a tuple, so unless someone is specifically testing if something is a torch.size, this shouldn't actually matter in practice. But it's not good to be doing naughty stuff like this. So we want to make sure it's actually matching. I can try to minimize the repro if you like, but I'm guessing it is very obvious that we are not doing this correctly. Okay, so that's good enough for this bug report, whatever, fine. Okay, so back to the story, right? So I entered this debug statement, and in fact, it changed the behavior of the program. So the error is no longer the same. Instead, I'm in some sort of like none type object has no attribute contiguous. Okay, that's kind of weird. That might be a real bug in and of itself, but it's not the bug I'm interested in. So I'm going to remove this print statement. Just a general thing about debugging Dynamo code is that Dynamo is adapting to what you do, right? Like normally when you have a Python program, you can debug it by just going ahead and making modifications to your program to just see what's going on. But Dynamo is like looking at the bytecodes you give it, and if you give it certain bytecodes, like a print bytecode, it's going to be like, I don't know how to do that, and it's going to do something completely different. So when you want to debug Dynamo code, we either need a print statement that Dynamo agrees does not cause a graph break and just dumps what the whatever Dynamo thinks the current state is. That would be a good idea, but according to Voz, we don't actually have this yet. So stay tuned. Someone should add this to Dynamo. It would be a very, very useful feature. But essentially, when you're in this situation, you cannot debug the problem by adding print statements, which is the normal way we love doing things. Instead, we should use a debug trace. So let me go ahead and revert all of my changes so that I've got a fresh slate. I want to revert this print statement as well. I don't have to revert this print statement, but did I revert this print statement? I guess I did. Let's just check. So this is in benchmark, and let me just check my status in this directory. Okay, no changes. Great. So what we're going to do is we're going to start tracing. So let's unstash that change that I just stashed in Dynamo before we started, and let's take a look at what's inside this working directory. So what I'm doing is I'm changing the logging level of Dynamo to be debug. I've already run it, and I've already put it inside of run.log. So let's just go ahead and look at this file. So this is this file that I was showing you. Okay, so this is what happens when you run torchdynamo in trace mode, which is you get so many lines. So I've got 32,000 lines of log. What the heck is going on? So there's a bunch of things going on. So let's just, okay, I really want to keep my spot here because this spot is important. But let's just page around in this other buffer. So what is going on in this other spot? So there's a bunch of stuff. So, Dynamo's like, hey, here's the original bytecode of the function. Here's what I'm modifying the bytecode into. Here are the guards, blah, 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 blah. In some cases, it actually produces graphs. You can see a lot of this, blah, 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 blah. You see these trace things. This is what happens when Dynamo is tracing through the execution of the bytecode. It's telling you, hey, this is what's happening every given step in question. Those are the trace things we're actually going to be interested in looking at. Let's look for a graph. It's also going to print some stuff like, here is the compiled graph. Yeah, here's a compiled graph, right? Which is just this giant table. I can make this a little wider. Oh, nope, I didn't want to do that. It's still not wide enough. By the way, I don't know why people like printing FX graphs in this tabular form. Like, it's so bad. Like, you can just get some Python code instead, and it's so much easier to read. But for some reason, people love printing out these tabular formats. I have no idea. This is an FX thing. Maybe someone on the FX team can explain this to me if they watch the stream later. But wow, what the heck? Anyway, so there's a whole pile of gobbledygook. And so one of the sort of problems with, logging is, you get way too much information. You're like, how exactly am I going to find the stuff that I'm interested about? So let's go ahead and think about, what do I expect my program to do? So I need to bring back the file that we were looking at, and we just want to take a look at what's going on. Where the heck am I? What am I doing? Shape. Oh, this is the call site. And this is, sorry, that's the place we called, and this is the call site. And here there should be like a shape somewhere. Shape. Come out shape. Input shape equals. Here it is. Okay, here's the code. I could have gotten it with a backtrace, but I'm cheating. I see. Yes, thanks, Jason. Hey, Jason Ansel, the author of torchdynamo is here and hanging out on the chat. Say hello. And yes, we should change it. Okay, so what's going on? So we've got this code. It's doing some input shapey stuff, and then it's going to destructure, and then it's going to go ahead and call into get extended extension mask. And as we recall from the backtrace, which is a bit far away now. Here's the backtrace. So the backtrace says that we were in the forward call. We called get extended attention mask. That called create extended attention mask for decoder. And then that finally got us to the destructure that said, hey, this is an int, not a tuple. So that's the problem. So what we kind of want to do is we want to to find out what happened. Like we're like detectives. We want to find out what happened in between the point in time when we allocated this input shape, this code, which actually calls size, and then when we actually went ahead and tried to use it in this point in time where it, blew up. And so to figure that out, we want to look at the trace, right? The trace is going to tell us what happened in torchdynamo every step of the way from this point in time to there. And to do that, we need to figure out where in the trace we want to be. Now, if you're me on this live stream, past me figured it out. But let's see how I figured it out. So the way I figured it out was I was like, okay, well, what exactly am I doing? So what I'm expecting is I'm expecting some trace calls involving input shape. I don't want to search for input shape yet because there might be lots of references to it. It's going to run a bunch of code. And what I'm expecting to happen is I'm expecting to hit this get extended attention mask. And I'm expecting that, okay, I want to just trust. I want to trust I can find this point in the trace again. So I've lost my spot. What I'm expecting to happen is I will make this function called get extended attention mask. So let's grep around in this file for this thing. So get extended attention mask. So this is the dump. This is just Dynamo telling us what the pre-existing bytecode for the Python object was. So I don't care about that. Okay. So now what do I got here? So I got this load adder, get it extended attention mask, blah 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 blah, and then I see this inlining code object get extended attention mask. Because remember, the way Dynamo works. Why I keep saying remember. So if you don't remember, you should go check out my other video about, deep dive into Dynamo internals that talks about what symbolic tracing is, what is Dynamo, what is all this. Yes, this podcast this cast is not going to make any sense if you haven't watched that one. So go watch that one first. I'm going to assume you basically know what Dynamo is doing at a very, very high level. So what's going on here is Dynamo's like, hey, we're getting this function call, and I want to just go ahead and inline this function call so I can figure out, I can keep going. I can see into functions and get a single graph that spans over function calls in this situation. So this is really good. So I think that this line corresponds to when Dynamo was executing this line of code. Do I get a line number? I don't get a line number. Too bad. Modeling T5, modeling utils. It would be really nice if these had line numbers, but it's okay. So I think this is what's going on, and I can look a little bit in the past, and I see, hey, here's this past key values, store, and hey, look, earlier in the code here, I store a variable to past key values. Where is that one? Oh yes, let me tell you all where that one is. So it's all on my YouTube channel. Haha, YouTube channel. Please don't mind all the weeb music. Yeah, it's okay. My channel, and check out this one, torchdynamo deep dive. And I'm going to copy paste this into the chat so you can take a look. If I can actually copy the link address. Oh, my bobbing face. I cannot copy paste it in the chat. Let's see, does this work? Oh, come on. There we go. Okay. So you can go check that out if you feel like you need it. Okay, so we think we found the smoking gun. So all we need to do is sort of walk back in this history and look for where input shape is. So let's go ahead and search for input shape. And fortunately, we don't have to go far. See, get extended attention mask. Hooray. So load fast. Do I expect to load fast? I don't feel like I expect to load fast. Oh, no, that's okay. Yeah, maybe I do expect to load fast. So input shape, input shape. Where's the store? Oh, here's the store. Oh, fancy. Okay, so here we go. So this is where we first stored input shape. I'm actually not sure which condition branch we're in. We'll figure that out from context clues. We actually, I figured it out immediately, right? Okay, so first we store input shape, and then we load input IDs. And so I know that then we have to be in this branch because the load for input IDs is right here because we're about to view it, and we can see indeed we do a view. Okay, so great. So let's just think about this line for a moment. What's going on? So Dynamo summarizes the state of a stack. So it doesn't actually tell me all the information. So if I wanted to tell me more information, I'm going to have to go and edit Dynamo's source code. But this is good enough to start. So what it's saying is that, hey, when I am storing a value into input shape, because that's what the thing is going to do, what I'm storing into it is a dynamic shape variable. I'm guessing this is, I have no idea what a dynamic shape variable, but the name is pretty self-explanatory. I'm guessing it probably refers to just a variable that represents some sort of dynamic shape in torchdynamo. So let's go ahead and check that real quick. It's a tensor variable. That's surprising. I was not expecting that. Dynamic shape variable. The tensor variable. Has some stuff. Okay, I have no idea what this means, but I'm expecting it means some sort of like, hey, you know, this represents a shape, right? And that makes sense, right? Because we called size on a tensor. We're expecting some sort of shapey variable thing, and we're going to go ahead and do that. The shapey variable thing is great. So if I got a shapey variable thing when I actually did the destructure at the at the exception site, I wouldn't expect it to raise an exception. Actually, can we go ahead and jump ahead? Okay, so okay, we inlining. Okay, so Dino prints a bunch of stuff, does some more stuff, and then it inlines this thing, dtype. Well, dtype is probably pretty trivial. Whatever. It inlines get head mask. Is that what I expect? Get head mask. What did the backtrace say? Get head mask. Okay, probably on irrelevant. Oh, we've got a lot of trace to dig through. Trace. La 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 la. I'm scrolling really fast now. La 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 la. Okay, we'll figure this out later. But basically, I'm expecting this dynamic shape variable to survive all the way through. And so if it doesn't survive, then there's a problem. So yeah, so now I want to track what happens to this variable. It's like a mystery, right? And for example, we see that when we want to do a view, and to do the view, we need to load some arguments. So here's the -1 variable for the view. Oh yeah, this is the state of the stack. So is it after the operation? So after I load a -1, oh, this is probably the state of the stack before. Oh yeah, that makes sense. So actually, when I called size, that pushed dynamic shape variable onto the stack, and then when I store it into the variable, that clears the stack. So for example, when I want to go ahead and do this view operation, well, what exactly is going to be on the stack when I do the view operation? Well, there's a tensor variable, there's a view method. Why are there three constants? Oh, it's because no, that doesn't make sense. Why? Oh, because this is the subscript on input shape. So this is only operating in the top 2 elements of the stack. So after that happens, I get another dynamic shape variable. Another dynamic shape variable? Someone in the chat said something. So am I understanding this correctly? At this exception site, we're expecting some sort of shape tuple, but it's an int, and we're trying to figure out what changed between the assignment and the exception site. Exactly. At the beginning, we should have a shape variable, and that's what we see here. And shape variables probably are okay, although now I'm questioning myself because this indexing operation gave me also a shape variable. And at the end, it's not a shape variable anymore. It's just a plain integer. I can't destructure it, and that's a problem. So yeah, that's my plan. And I've never done this before. So like I'm figuring it out as I go along with you all on this live stream. So where was I? So that's kind of weird. So I wasn't expecting that. So this binary subscript is exactly the, it would be really nice if like we had a like mini decompiler for these opcodes that would like be good for people who aren't used to reading binary opcodes. Well, whatever. Fine. Most people aren't going to be looking at traces like this. Okay, so I had my input shape, That's my dynamic shape variable, and I have -1, which is my constant variable, and I'm going to binary subscript it, and the result of operating on these two things is a new dynamic shape variable. That's kind of weird. I wasn't expecting that. I was expecting like this to be an int or something. I guess we use dynamic shape variables to represent both tuples of shapes and integers of shapes or something. I guess that's probably what's going on. Seems a bit suspicious, but let's keep going. Okay. And then we call view on these two arguments, and it gives me a tensor output. Okay, so that didn't really tell me anything. So okay, so what's our plan? So our plan is we're gonna chomp through all of the traces, all the inline. There's a lot of bytecodes to get through. It's kind of a pain, and we're just gonna look at what is going on with input shape. So as long as I'm in this function, input shape is referred to as input shape. That's pretty nice. And eventually, I'm going to what? I'm going to call get extended tension mass with input shape. So let's just make sure that it's looking all good. So we load input shape one last time. It's a dynamic shape variable. I hate this. I hate this because we looked at this input shape -1, and we saw that the result of indexing into the input shape gave me another dynamic shape variable. So I'm not actually going to be able to tell from these debug prints whether or not I have a full tuple or I have a singleton element. So, and Jason Ansel chimes in on the stream saying, yes, we use it for both. There's a property on it to test the difference. So I'm going to have it print the property for now. There's another question, which is we're unable to just log out what the input shape is, you said. And the answer is no, we can't. We can't put print statements in the Python program, but we can put print statements inside Dynamo itself to log it out. But I don't know where to put those print statements. So let's go ahead. So we're going to regenerate this trace. It's going to take a little bit of time, but I think it's going to save us a lot of time in the long run. And to do that, I need to go ahead and figure out, I need to make dynamic shape variable print more stuff. I think I want repr on this. Let's return the default repr. No, I don't want the default repr. Default repr is so bad. Dynamic shape variable. Okay, so Jason said there's a property on it to test the difference, but I don't see what property I would use actually. It's probably one of these two things. Maybe dynamic shape length. Yeah, I like dynamic shape length because so it's not clear. See, it would be really nice if we had like some documentation or some like type annotations, but I see that we're testing if dynamic shape length is none or not. So I'm guessing that when dynamic shape length is none, that means that you have just an integer, and otherwise you have a tuple. So let's just go ahead and print that in the statement here. And Jason Ansel confirms len is none for single values. Excellent. So we've got that, and let's go ahead and run this with a lot of debugging and put it in our run log. And I'm going to keep our old run log because I don't want to throw stuff away. Okay, so while we're waiting, let's think about what is going on. So what am I thinking about? We can add some documentation. Oh, another way to figure out, like, so if you don't have the author of the code, like, hanging out at your live stream while you're live streaming, you can always figure stuff out like this by, like, sort of looking at the commit history. It's still running, so let's go ahead and look at the commit history. So, cd torchdynamo, git log, this file, and then this is going to result in a lot of log entries that probably don't matter. Yeah, a lot of log entries. Oh, it's done. Okay, we'll have to do that thought. I was gonna tell you about pickaxe. Pickaxe lets you like just look for only commits that have the log message in question. So this would be dynamic shape, and then you can see hey. I've got another hypothesis now, by the way, which is I'm wondering if this is related to torchdynamo dynamic shapes being on. And I have to try this, sorry. So we're gonna go ahead and try this without torchdynamo dynamic shapes and see if this actually solves the problem. there's another question, which is, when does one get used to looking at complex Python code? So much of this seems to be entirely inscrutable to me. Well, yes. This is one of the reasons why I'm doing this live stream. It's because I think a lot of people find it hard to debug a complicated code base that they have never worked on before. And I want to show people what it looks like for, someone who, yeah. So as I said, I didn't write any of the torchdynamo code. I did spend a live stream like poking through it, looking through it. I know what, in principle it's supposed to do. And so one of the reasons for doing this live stream is to show you, hey, this is what I think about when I'm looking at stuff like this. And hopefully, it'll give you some ideas. Now, for this particular problem, you probably need a little more context to like really grasp everything that's going on. So I'm actually mostly recording this live stream for folks on my team who might be interested in knowing this. Hey, look, actually, it looks like we've gotten through this and it's not erroring. So we might actually be hitting a Dynamo bug related to dynamic shapes support. I don't know if I want to keep waiting for it or not. Yeah, it's probably, hey, it passed. Oh, incredible. Oh man. Okay. So what this means is that we have a Dynamo dynamic shapes bug. So we might actually be able to submit a bug fix to the Dynamo repo when we're done with this. So exciting. I love it. Okay, let's look at our run log. Okay, so maybe I can just search for input shape and it'll get me straight where it needs to be. Yeah, excellent. Look at this. So now we've got a number, and this tells us what the size of it is. So we've got a two-size tuple, and then when we actually subscript into it, so remember the subscript was asking for the last element, it becomes dynamic shape variable none, saying, hey, this is a dynamic shape variable that doesn't have anything. So let's keep going. Okay, so we load this, and it's still a dynamic shape variable too. So hey, we're in business. And actually, this is a great idea. What we can just do is we're just gonna look for dynamic shape variable in the trace because it probably refers to the input shape we're talking about. And we'll just use context clues to figure out what's going. So let's keep going down the trace. So next site. Okay, I was wrong. So actually, it looks like we're loading the shape of hidden states and doing some stuff with it. I don't think I care about this. So let's skip it. What's this? Where did we get this from? This is the batch size. I expect batch size to be a number. That's fine. What's this? This is another batch size. I don't care. Another batch size. I don't care. As I said, the problem with traces is there's a lot of trace. So like knowing how to skip past stuff that doesn't matter, really, really useful. This doesn't look like it matters either. Okay, yeah, skip. This doesn't look like it matters either. There's so much random crap I don't care about. Forgive my language. How far are we? So 6850, and I've got 30,000 lines of trace to go. Okay, I might need a better strategy. Let's do the strategy of keep going next. Keep going next. How far am I skipping? I skipped 2,000. I guess I can brute force this. Okay, new idea. Let's just go to the error, and then let's just look up. That's interesting. I went a lot further than I expected. Why? That's weird. What is that? So we got a bunch of trace, and then we got some stuff. Oh, that's right. So at the time we were over here, yeah, okay, so new plan. So my original plan was look at the original call site and then go forward from there. That was really useful for understanding what I expected the shape to be. I expected it to be a dynamic shape variable. Hi Mark, welcome to the stream. Thanks for coming. Sorry, I'm not going to explain again. So you should 2x speed the history if you want to get up to speed real time. Okay, so where am I? So originally we decided we were going to go from the call site and then go forward, but there's a ton of bytecode we processed along the way, so I just got lost. So what we're going to do instead is we're going to go from the end and look to see like where things go wrong. And we can see that things have gone wrong because at the time we're going to unpack something from the sequence, we have a constant variable int. That's bad. I don't want that. That's blah. So let's see. So I'm looking, I want a dynamic shape variable, and in particular, I want a dynamic shape variable none. So let us track what is going on. So this is loaded from input shape. So let's look at where input shape is populated from. Input shape is populated as an argument, I think. So user function variable. Okay, so when I load input shape, sorry, this is the state of the stack, not the state of the stack after the instruction. That's kind of confusing too. I wonder if we should like change the convention there. Jason, if you want to chime in the chat. So constant variable int, because it's after the instruction, right? You'd expect after the instruction to get the state of the stack after you had run the instruction, but no, actually it's the state of the stack before you run the instruction. I don't know. Okay, so this is still wrong, and so that's good. And so let's see. So we want to look at where input shape gets set. So much stuff. And here it's a dynamic shape variable. Right. So I was expecting to see a store fast for input shape, but I guess because input shape is an argument to the function, that didn't happen. So we need to find the function call site. To find the function call site, let's look at the backtrace. So here is where things go wrong. Line 774. JSON supports changing it. We print it before we modify the stack in case there's an exception before the instruction finishes. Yes. That is a very good reason to print the state before. I retract my suggestion. I really do want to see the instruction that is going to be done. So I guess we shouldn't do that. That's too bad. No, that's a really good reason. Okay. So what's going on here is input shape is being set when we call in the function. So I guess when you do Python bytecodes this way, there's no bytecode for like loading up the arguments, which makes sense. Whatever. So we need to figure this out some other way. So we want to look at the call site, and the call site is this file. What's going on here? So so we're looking for a call to create extended attention mask for decoder. So let's just go ahead and look for that in the trace. This is while things are still good. Okay, here it is. Load this attribute. Load some stuff. This looks very naughty. Okay, so we've already messed up somewhere along the lines here. So this is the key. This is the key spot. So I need to figure out why input shape is a user function variable. But we know why it's a user function variable. It's because in this function, input shape is an argument, right? Of course. So we must go deeper. Inception. So we need to go to the next line in the stack trace. Oh yeah. This is what I was complaining about, by the way, because this line in stack trace is wrong. But Jason's already told us how to fix it in the issue, so someone should just go pick up the text and fix it. Why do I already have this file open? Let's go back to this file. Okay, 892, and then what am I calling? I'm calling get extended, but it's not called that. It's actually called, what the heck is it called? Get extended. Oh, no, wrong file. This is the torchdynamo file. That's why I can find it. 892 get extended attention mask. Yes. And let's look for that call. You know, if I were Jason and I'd written the code, I'd probably know what the problem was already. But I don't know any of the code, right? I have no idea what the code is doing. So we need to figure out where in the code we're going to look for, like, you know, the thing that seems to be going bad. Okay, so here's get attendance extension mask. And at this point in time, when we call this function, we've still got dynamic shape variable too. So we've got our transition point. So it is this function call where before input shape is a dynamic shape variable, and then after this, it's not a dynamic shape variable. And this actually kind of makes sense, because if the bug is something like when I do function calls with dynamic shape variables, they turn into user function variables, which seems very plausible to me, then I would expect the first function call with input shape to actually trigger this problem. And indeed, well, let's see if we can find a smoking gun when we call this function. Load const 2. What is load const 2? Okay, I actually do want to look at this function. So I don't remember how function calls work in Python bytecode. Well, let's see if we can figure this out from first principles. So my original idea for how this would work is when you do a function call, the arguments would be all on the stack at the beginning, and, you know, life would be good. But you can see that at the beginning of this function call, there's nothing on the stack. So that's wrong. So that must mean the arguments are somewhere, and I need to get at them via some bytecode. And I don't remember how this works. Let's see. Jason says locals are pre-populated with args. Oh, great. So yeah, that's why I don't see input shape until I actually try to use it somewhere, like this load fast. Okay. By the way, if I didn't have Jason on the line, then I would have just gone and looked up the documentation for Python bytecode to, like, figure this out. But it's very nice having someone on the line who knows all this stuff off the top of their head. The benefits of actually knowing what the heck you're doing. So this is oh no. Is this right? This is create extended attention math. Oh, no, this is fine. Oh, this is very confusing. So we're actually doing another function call. Create extended attention mask. Can we find that? Wait, did I jump too far? Let's do the time warp again. I think I jumped too far. Shoot. It's just a step to the right. Okay, I'm very confused, so I need to unconfuse myself for a second. Okay, so let's figure this out again. So the way I was figuring this out was I was going back from input shape here, and at these input shapes, I had constant variables, and then at this input shape, I had a constant variable, which is also wrong, and then this function is the one that calls create extended attention mask for decoder. And so what I'm expecting is another input shape, load, and then this one has a normal dynamic shape variable, and I'm expecting what the function call is. The function call here is is this a graph break? Is this a graph break? Is this just fantasy? Caught in a landslide, no escape from reality. Open your eyes, look up to the sky and see. Yeah, because if it's something as simple as just calling a function with a dynamic shape variable, that probably actually would have worked. So there's got to be some sort of twist. So I'm feeling like the twist is some sort of like graph break or something like that. But I just don't understand what this trace is doing. So let's read it again. Okay, so we got a trace graph. Now, what I would expect is if I was doing a graph break, I would expect there to be a graph break error message. But there is no graph break error message. So that implies that I finished tracing a graph. Why have I finished tracing a graph? So I enlist this thing. I am very confused. So how come I can't find this? How come I can't find this function anywhere? It's so weird. Where is it defined? Let's look at this file. By the way, if you're on the stream and you know what the problem is, or you got a suggestion, just shout it out. Like I'm figuring this out just as much as anyone else is. Yeah, I really wish there was a way to like fold these traces so I could like just jump over stuff that wasn't necessary. Yeah, so my problem right now is I just don't understand the high level structure of the trace that's going on. Like what I expected was to go in a straight line from when I allocated input shape to the end, but you can see that there's a graph emission in the middle, and that's this graph. So I don't know why we're emitting a graph. And this probably has to do with why the bug is happening, but I just don't know what is going on in the code. Okay, I need to think for a moment. So the chat has any questions, like please pile them in. I'm just going to I'm literally going to sit here and just ponder. Output graph, trace pop jump is false. It's not a graph break. There's no graph break here. This original bytecode is really annoying because it's very long. And then here's the modified bytecode after we modified it. Here's the guards. And then we go back to tracing. And here's the input shape, and now our problem. But why did we finish? Why did we finish doing the graph? Is there print? I really want there to be a guard log message, but there's no guard log message. The bytecode dump is so long. We really need logs with folds. Vim supports folds, so maybe we just have to output the right markers to like let it do folds. I also don't know how to use Vim folds, so that's a problem. Trace graph. Maybe we can figure out what function we're finishing the graph for. It's create extend intention master decoder. Let's call function with a user function variable, dynamic shape variable. Okay, I don't know why we're outputting graph. This is weird. So I wanna figure this out. Okay, so we're gonna look at Dynamo now. Jason Ansel chimes in, I suspect it's a graph break issue. I suggest printing the state of, let me just pull this over. I suggest printing the state of symbolic locals when instruction translator is done constructing. I suspect it is graph break issue. Yeah, so this is why it's great being the author of the code, because I have no idea what this is, but we'll find out very shortly. Okay, so see, I don't even know what instruction translator is, so I'm gonna have to look that up. It's this guy. Oh yeah, instruction translator is the symbolic evaluator. Oh yeah, I'm also like, one of the things I'm doing is I am kind of debugging on hard mode. So like if this was code you had written, you'd probably like already have like added print statements and like started like mucking around with stuff. But I don't know this code, so like I've got to get a really good idea of what I'm looking for before I actually start like messing around with stuff, because messing around with stuff is really slow. Like, you know, everything you do in your brain, instant. So you want to do stuff in your brain first and then figure it out on the line. So let's just do this print here, self symbolic locals. Do I want a preprint? I want a preprint. Okay, let's run it. Another good thing to do if I'd actually written this code was I would like go and look at, is this correct? Oh, no, this is not right. I need round 3. Another thing that was good is like once you've gotten to this point, right? You're like, oh, I think it's a graphic issue. Is you want to like, you just read the code that like does the thing in question and see if there's anything that looks suspicious. Unfortunately, I have no idea what this code is. So I can't, I don't know where this code is, but like, tag to search for? Yeah, that's a good idea. Okay, let's do this. Print symbolic locals. Also, a lot of people would have like used PDB here, but I hate PDB. Like PDB is so bad. I don't use PDB. It rots your brain. Actually, PDB is great. Like especially when it takes a long time to like get to the spot that has a problem. It saves you a lot of time doing a lot of like tests, but like in an ideal world, like record replay would like be good, and you can go forward and backwards in time, but like it's kind of slow, so I don't have record replay. And if it's kind of slow, I just don't want to have to like deal with waiting for the thing to figure it out. I don't remember how output graph works. How do I output code? Does it compile subgraph? Hey, it's running. Yeah, so there's some sort of like create call, resume at business. So I'm like looking for like something where you're like, hey, like, you know, we analyze the live variables and then we reallocate them and blah, 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 blah. But, well, it's done. Okay, let's look at our log. I want to look at my chat. Our distributed PyTorch jobs, like what all it is, treated the same way as normal ops as Dynamo is concerned. We want distributed PDB. Yes, they should be. Oh, I don't know if I want distributed PDB. That sounds crazy. That sounds really crazy. But I don't know how to debug distributed problems. Like it's just not something I really have figured out how to do. Okay, so let's look. Wrong. But we knew that. Wrong. But we also knew that. Yeah, these are like some random side functions that we like went into. Then maybe I didn't put the print in enough places because this looks really early. Oh no, I'm pretty late in the trace. Line 30,000. Okay, I don't see anything relevant here. Nope. Am I going forward? I'm going backward. Yeah, this is annoying. I don't have enough prints. But there are a bunch of subclasses instruction translator. Actually, where is symbolic local set up? What does variable tracker apply do? Yeah, I'm just reading code right now. Copy graph state. That seems like it should be okay. This is where we construct symbolic locals. Oh, is this the base class? Oh my god. Why is the init function so down? I wish Vim could tell me. Did I edit this? Okay, let's print it here. No, I don't want to print it here because actually it's some stuff. Well, but I will print this one. Well, let's give this one a different one. Name. This is the one I did print. Yeah, this is the one I did print. Let's move it closer to the assignment. I'm flipping through this pretty fast, but I am reading all this code because I'm trying to get like ideas for like where the problem could be. Like if there's something like transforming over the symbolic locals, that seems sus. Because that would be a good place to like lose the information. Prune dead locals. I think that's it. We looped around, right? Yeah, we looped around. Okay, let's run again. And now let's think about what we expect is going on. Yeah, so some people, when waiting for a run like this to finish, would like go work on something else. But when you're debugging a really hard problem, I think that's bad. Like when you have downtime like this, you have to think about what your strategy is. Because like just randomly trying stuff out is a bad idea. Now, unfortunately, instead of thinking strategy, I'm talking to you on the live stream. So I have thought of my strategy. Okay, so let me think about my strategy. What is my strategy? So that transform over symbolic locals, that variable tracker apply, that looked kind of sus. So let's go ahead and look at that right now. Oh, so many. And what does it apply? So walk this object and call a function on all of them. And REPL is basically, hey, if mutable local is old var mutable local, return new var, otherwise v, some sort of replacement. I kind of feel like this has got to be the problem. Okay, next time around, I'm going to add some print statements here. There's a comment from Jason. If you have a live dynamic shape variable, then you do a graph break, Dynamo needs to call the continuation function with a concrete value. I expect it to construct a graph that returns a shape, then call the resume at x function with a return value of the graph. Let me think about that. Okay. Then it might be our fault actually, because with dynamic shapes we should be returning a graph variable. So we're probably doing something wrong when we're returning the graph variable. Oh, okay. Let's look at that graph break. I'm still so mad that I don't get to see I don't get to see why we decided to emit a graph. Like aren't I supposed to get messages when there are graph breaks? Poopy. But that would explain it. I don't know. I want to look at the graph. Oh, this is fancy. Look at this checkpoint. Oh, beautiful. So we didn't have this print last time, and it's got an input shape. That's correct. And then we do the graph. We output. The output is a size. Thanks, Jason, by the way. That's really helpful. Like that I was not thinking about looking at the graph that was produced by the graph break, but we can see that there is a size call here. Does that matter though? I'm not sure that matters. Well, whatever. Okay, so make this wider. I wonder if anyone's chatted on work chat. I'm distracted. No one's here. I just have no freaking clue what the heck any of this crap means. So I'm gonna change the trace graph printouts. I'm gonna add that. And add the print I also wanted to see. Okay, so self symbolic locals for update locals and stack. Update locals and stack. And I need to find where the traced graph print is. By the way, something you're not going to see on the stream, but I'm going to do later, is all this stuff I'm going to try to upstream as best as I can. See, someone specifically called graph format tabular, and I have no idea why. Why? Why would you do this to yourself? Does GM graph work? Are we on the Python code? Maybe GM graph is okay. There's also like a print readable, but I'm not sure I want to try that. Well, let's see if this works. Okay, while we're waiting for this to run, I want to think about Jason's comment again. If you have a live dynamic shape variable, then you do a graph break. Dynamo needs to call the continuation function with a concrete value. Why does it need to call it with a concrete value? Oh yeah, and he's a. Oh, this is very interesting. So there's actually like this poses a problem actually, which is we need the symbolic integer support in Dynamo. So Dynamo has this. Well, I don't know if they fixed it since the last time I knew about this, but Dynamo originally had this problem, which is that it would specialize on integers and floats. So like if you had a Python function and it had a just like a integer or float or whatever inside the program, yeah, you're getting a separate function for each of these. So there is some heuristics for deciding when to specialize or not. I wonder if these are relevant. What's the default though? It could be related to this code actually. Well, I'm not sure. Okay, let's do this back. Yes, Jason says it's because of an error call. That's why, and that makes sense. But it means that if we wanna like turn that back into a dynamic shape, we have to know that that integer should be treated dynamically. Otherwise, we're just gonna bake in a guard for it the next time around. So that's bad. Okay, so we got to the error. So look. Okay, so what did I want? I wanted to look at the graph. So let's look at the graph. Getting very cozy with this trace. So where's the graph? Come on. It's like users, right? Yeah, here we go. Oh, I wish I had Python code. That sucks too. Size is call method size on input IDs. This just doesn't look relevant. Maybe there's some other trace graphs. This one's very long. This is a very long trace graph. A lot of get items. Where are all these get items? What's this? Oh, I want to file an issue about this. There's another comment from Jason. Let's read this comment. The config specialized in float might be able to make Dynamo treat the integer input as dynamic, but we need some way to pass that dynamic shape system as a symbolic integer. Yeah, I'm gonna ask Horace about this tomorrow, I guess. I have no idea what I want to do there. Okay, hang on. So my bug report is Dynamo shouldn't name. This is an FX bug report. No, it can't be an FX bug report. Shouldn't name get item variables get item. Instead, it should derive the name from the variable that was get itemed. This would make return statements like a lot more informative. Okay, so I said this looked kind of sus, and why does it look sus? Well, it's because we've got this size. So this size is basically saying, hey, given the output of the multiply, tell me what the size of this thing is. And then, but is this the code? Is this the relevant code? Next time I run this, I want the Python. I want generate Python code. Jansel suggests a minimal repro. Yeah, okay. We need to convert that function arg into a symbolic size. Let's. All right, let's try minimal repro. Okay. Oh, I don't get a context manager anymore. I need to induce a graph break though. What does Jason say this repro should do? Oh no, this is the repro for the specialized in float thing. But maybe I can do the repro. Let's do it. Let's try to make a minimal repro. Minimal repros are kind of tricky to do, but like if you get a minimal repro, it makes life a lot easier. Also, like, I guess hypothetically the minifier should have worked, but I don't trust the minifier. I probably should have tried the minifier. Oh, let's try the minifier. Oh, I feel bad not trying the minifier. Let's try the minifier. And while that's going, we'll work on the minimal repro. This is very bad of me. I should have tried minifying first. Even if I don't trust the minifier, if it does work, it's a huge benefit to like not have to deal with all of this random crap. Okay, minimal repro. So what I want to do. So what I want to do is I've got my tensor. Let's do some diddly compute on it. Don't want to duck size it. I don't think that'll matter. And then I want to compute a shape from it. And I want to create a graph break, arf. And then I want to use the shape. That should be good enough. Let's try that. Oh, and I need to turn on dynamic shapes. The heck is this? Yeah, I filed a bug report complaining about how that didn't work, by the way. It didn't fail. Too bad. Too bad, dog. No biscuit. Size. What if we like slice it? That didn't work either. Alright. So much for mini repro. I don't think the minifier worked either. Well, it says it dumped something. Minifier launcher. Oh yeah, whoopsies. Okay, let's do some. Okay. Return y times x times x view. Ha! I turned them all into concrete variables. But I might have messed this up. Actually, maybe I shouldn't have done that. So getting rid of that. Nope. Did not fail. got some inputs. It's hard coded. The graph does return a size. And then when we load the size, it's a unpack sequence tuple variable. It is a tuple variable, yeah. So that's too bad. Okay, it looks like it's more complicated than that. Okay, it might be worth trying the minifier approach, but I don't know how much longer I want to keep debugging this. Oh yeah, sorry, I was going to check if it actually dumped a file. Let's check if it dumped a file. Minifier repro. It's like what, temp easy yang minifier. Okay, it doesn't look like the minifier worked on this one either. What I'd give for a minifier that actually works. Oh, I did want to pre-print this. I want to know if it takes multiple objects. It does not appear to take multiple objects. Get that running while I am quiet because I don't know how to make more progress. Might want to just go to sleep. Oopsies, I should have not piped this. I don't feel like fixing the minifier. I mean, it would be good, but that's more code that I don't understand how it works. Okay, it looks like that run finished, so let's just pull up that run. I'm just randomly looking at code right now. But this one doesn't matter. All right, comment from Twitch. So we're reasonably sure that this is an issue that pops up during the graph break. No, we don't. Like Jason thinks this is probably what's going on. I think it's very reasonable. We don't have strong evidence that this is happening. One reason we don't have strong evidence is I don't actually see graph break in the log anywhere, which is very annoying. Like, why is there no? The heck is this? Okay, so there is a graph break going on. Yeah, there is a graph break going on. We know like a very basic minified repro doesn't act. Sorry, a minimal repro that we attempted to make doesn't trigger it. So there has to be something complicated going on. Yeah, I'm happy to like guess that it's a graph break, but I don't. Yeah, I just don't have a good enough understanding what I expect to see here to know how to like figure this out further. Yeah, like here's a size that's being returned here. Actually, can I figure out what this code is? Oh, isn't this the code we were originally looking at? This looks like the code we were originally looking at. Do I sound perky? It's because I am grasping at straws right now. Heck, it's modeling T5, I think. Yeah, here we go. Is this the code I was looking at? You know, it'd be really nice if we preserve the variable names. And Dynamo even knows what the variable names are, so I don't even know. Yeah, Dynamo, you don't have any excuse. Is there an issue for this? I want to complain about this and ask if there's an issue for this. Oh, Jason Ansel says the minute repro did reproduce the dynamic shape variable becoming an integer constant. You just need to figure out where the integer constant was causing it. It's true. No, I disagree. So the minimal repro did reproduce it becoming an integer constant, but that's what we expected to happen because when a graph break happens, we have to turn all the integers into concrete things. And because there isn't like, well, I mean, even if it turned into a dynamic variable, like whatever, like it doesn't matter. The problem we're dealing with here is that it used to be a tuple and it turned into an integer after the graph break. And that didn't happen, right? Like in the minimal repro, let's just run it again real quick. In the minimal repro, what instead happened was that, should I run AOT autograd? I just want to check something now. Does this fail with eager? Look at the code calling resume at X. Yeah, that is a very good idea. Yeah. What did I? Okay, let's run this experiment in my other terminal. Jason says, we know resume at X was called with an integer, so either graph returned an integer or the code unpacking the graph results is wrong. Yes, that seems very reasonable. I just don't know which log to look at. Oh, does this fail? Please fail. Oh, it passed. Okay. Well, what are my backends? AOT eager. No, it's got to be. Yeah, it's probably not a problem in Dynamo, actually. I was so chipper going into this, but I need to find a graph. Give me a graph. You could write a custom compiler function that prints out the return value of the graph and see if it's wrong. I mean, I can just edit the thing. I don't know which graph I should be looking at. That's what's causing me trouble. Because even if I print things out, I don't know which print I want. Like, is it this giant graph? I'm guessing it's this giant graph. Because this small graph, I don't think could be causing the problem. Or even if it is this small graph, I don't know. This is compiled fun 4, right? Okay, let's look at compiled fun 4. Oh, it is compiled graph 4. Hang on. Compiled graph 4. We loaded it with input IDs and encoder hidden states, and then we call this function. And then once we were done with it, we store some stuff. And there's like up top. We build a list. And then there's a resumption, which we call, right? What does this do? And then eventually we start executing. And when we start executing the load fast attention mask. Where's the load fast attention mask? It's probably this. Yeah, we started executing here. But at the time we got in here, there's a problem. Okay, so it's compiled fun 4. Good idea, Jason, making these have unique names. That's actually really useful. I forgot that this was a thing. Four variables. How do I know what these variables are? I'm not mutating it here anywhere, am I? Maybe this graph is fine. Yeah, I probably should listen to what Jason's telling me. I want to be annoying and not listen to it. And then I want to do what Jason tells me to do, and then it's going to be right, and I want to be sad that I didn't listen to him earlier. All right, let's do this. Let's do what Jason told me to do. I want to turn off the debug prints because I'm not getting stuff from them right now. And what's the OTE group backend? Okay, so we're back in code that I kind of know more. Func torch circ AOT autograd. Yes. Well, I don't know if this is going to work. We'll see. Okay, while we're waiting, let's think. So the current working hypothesis is that we have a graph break, and when the graph break happens, there is a bunch of compute, including size computation, which is being returned by the graph. Now, how do I know that size compute is being returned by the graph? Oh, this must relate to torchdynamo dynamic shape. So probably something like whenever we have a graph, normally torchdynamo only returns tensor outputs. But with dynamo symbolic shapes, it returns shape variables as well. Ooh, wow, that's a lot of printing. I should have deleted those prints. Oh, hey. Yeah, whoops. Yeah, I can't get the insides. Oh, okay. I know what the problem is. Thanks, Jason. See, exactly. I regret not listening to Jason. The problem is that when we wrote AOT autograd, we assumed we were only returning tensors, and furthermore, we were returning a flat list of tensors. But with dynamic shapes turned on, we can have tuples, and tuples count as pi-treeable things, which means they flatten away. So AOT autograd is returning complete garbage. It's returning a 1024, but it should have returned a tuple to 1024. And that's why we're broken. Okay, can we fix this in the rest of the stream? I want to go to bed before midnight. Yeah, I think I can fix this. Okay, so I know this code, so let's see. So I need to stop AOT autograd from looking into tuples when it pi-trees. So it's going to be AOT, it's going to create AOT dispatcher function. By the way, did that make sense to anyone who's still listening on the stream? Like I know what the bug is now. Like thanks to Jason's suggestion to print out what AOT autograd is returning. Jason understands. AOT dispatch autograd? Yeah, because we're doing training. Where do we do the outputs? Oh, this is a pain. Oh, but we're running compiled function. Agent Shadow Dark. So it was a thing that was the graph was outputted being used wrong by AOT. Jason says, I do. I think we actually deleted the pi-tree unflattened stuff as a perf optimization. Oh. Yes. I see. Yeah, but it's wrong now. But I'm not sure how to fix this. So, okay, so just to answer Agent Shadow Dark's question. So basically what's going on is torchdynamo is expecting the compiled function to return a tuple of size integers, right, as one of the arguments, right? So like Dynamo's like, hey, I'm giving you a graph, and one of the outputs of the graph is a size, and like I'm expecting you to return me a size for this case. But AOT autograd is like, hey, I'm going to give you a flattened list of random crap, and that flattened list of random crap is going to flatten away all the tuples. And if you had the arc spec for the unflattened thing and you unflatten it, that would actually give you a tuple. But no, as Jason says, they are not unflattening. So that's why you end up with this thing. So that's the bug. I'm not sure how to fix this. Like, what the heck is AOT autograd even? So I actually do want to look at the graph, and I'm not printing the graph anymore, am I? Rip. I really do want to see the graph. Oh, let's print the graph here. Oh, actually no. I've got a command to do this. Yeah, it's what? AOT joint. So I think I want a different one. Yeah, I don't want the joint graphs. I just want the graphs. Okay. All this running. Let's think about how we're going to fix this. Okay, so I think torch autograd function can support returning tuples and stuff, but we flatten it. Where do we flatten it? Flattening happens before we call this function because when I wrote the deduping logic, I was able to assume that it was a flat argument. So flat fun. And flat fun is the flattening already happened before we call create AOT dispatcher function. Which of I wonder what's in a wonder ball. Oh, Horace is up. Let me tell Horace. Yo, Horace. Yo, Horace. I figured out Brian's bug, but I'm not sure how to fix it. I'm currently live streaming. Lol. The bug is that we flatten size tuple. So you were supposed to return tensor 1, 2. We actually return tensor 1, 2 from AOT autograd. Okay. Yeah, so look at this. So it's flattened because sim size 1 is just a sim size. And I don't think we're allowed to like not flatten it. Maybe the easiest way is to change Dynamo's calling convention so that it knows to repack the tuple. Yeah, exactly. Okay, this live stream has been really long, so let's just summarize the situation, okay? So apparently, if you get help from Jason Ansel on your live stream, you too can figure out a bug like this, which is very, very interesting. Let's see, lessons learned. So we looked at the trace. We saw that the variable was changing. We improved some reppers. Hi, Horace. Welcome to the stream. Do you think we can fix this in 10 minutes? Because I want to go to sleep. So the bug is right. So the bug is that AOT is outputting this thing. So you got a tensor, and then you got 2, and then 1024, and then another tensor, and that's bad. This needs to become a tuple when it gets back to Dynamo. So we were just talking with Jason that maybe we should just have Dynamo expect flat simments from the compiler always. That certainly seems easier than trying to unflatten it. but I'm not exactly sure how to do this dyno thing. Why is it being flattened? Well, when AOT autograd does flattening, right? And then we just assumed that Dynamo would take a flat list of tensors. The reason it's problematic is Dynamo is expecting this to actually be a tuple, and so the size is becoming a 2 when it goes back to Dynamo. So it sounds like Dynamo is expecting the wrong thing, right? Shouldn't that all be handled with an AO2 autograd? Let me think. Do I agree with that? You want to join the live stream on a VC call? The original graph returns a tuple, so AOT autograd somehow has to do it, but we removed the unflattening logic. Okay, we're gonna do some janky guest thing in the VC. Okay, so file a VC. I don't even know if this is gonna work well. Oh, I need to pipe the audio as well. Let me see if I can figure this out. Audio. Input capture. Okay. Device is going to be loop back audio. Okay, the room's open. Hi, Horace. Say something. I need to check your levels.
Okay, wait. Can you hear me?
Yeah, we can hear you. You're on the live stream.
All right, I just turned off the live stream. Yeah, I just woke
up. No problem. We're really burning the midnight oil here. All right. So Horace, what do you think? How do you think we should fix this?
Wait. So the issue is that we don't. Is there issue that here because we're using AOT mod function simplified?
Yeah, probably because that one expects everything to be flat, right? But Dynamo doesn't expect that.
If that's the case, then yeah, I agree that we should just handle it at the Dynamo side.
Okay. Do you know how to fix Dynamo this way or not really? Like, can you tell me where to go? Because I don't know exactly where to put this. Maybe Jason knows.
Yeah.
It's like output graph, right? And it's gonna be dynamic shape related as well, because what the heck is the thing that triggers dynamic shapes in Dynamo? Dynamic propagation?
Yeah, I mean, I feel like it shouldn't be that.
Yeah, but I gotta do it in 7 minutes because I want to go to sleep.
Maybe this is not true, actually.
Okay, all right, we're giving up. That's the end of the live stream then.
Because you need to like make it not track the shape object, right? As a node, you need to make it track the like actual like underlying cement thing.
The actual cement thing, I guess. But Dynamo does know if the tuple is a list of integers or it's a single integer. So
yeah.
Oh, Jason. Oh, excellent. We need a custom reconstruct method. Yes, that's exactly what we need. I don't even know what a reconstruct method is, but I guess we'll figure this out tomorrow.
Okay. Wait, I do have another question or no. Like, so one of the things I had to do when I the original problem with like the get pi object constant was because we were returning cements from AOT autograd. So like the function.
Oh yes, you guys were like talking about this. I didn't follow that bug discussion, but yes, this seems very related.
So basically, when you removed a proxy tensor at some point, you also basically like it used to be like the handling converting a proxy cement into like a proxy. I used to live in like create arc, but basically after you remove proxy tensor, you also remove that logic and create arc. And so I think the idea is that create arc should never be called. I think that just ever.
Yes,
but
because we should never have free variables. We should always have them as explicit inputs.
Yeah, because we always interpose like whenever you actually like pass it in, or like when you're actually doing the operations on the cements. But the issue is that you also call create arg on all of the outputs to the function as well, because we need to put in like the output. No, I mean this is like an FX thing. It's like all of your
because
like
they need to go in the graph. Okay, sure.
Yeah, they need to go in the graph. Yeah, it's kind of a I really like. I was like, oh, like, do I need to modify create arc? But yeah, it felt like the right thing conceptually was to just interpose again before we return it, and it makes sense, right? Because we need to do a similar thing with the proxy tensor, where like we need to return proxies from the function. So, oh yeah, but one of the annoying things that I needed to do here was I couldn't like the tree map. Like there's like a tree map, right? And then so that tree map couldn't make it stay a torch.size object, because torch.size object expects ints, or I guess cement nodes in it. So after you tree map through it, I needed to like flatten it into a list and then unflatten it back into a tuple instead of a torch.size object. Yeah. So that's how I ended up in this state.
Okay. Jason has a new suggestion, which is to represent dynamic shape variable as a tuple of dynamic shape variables. I like this idea, but I'm not going to implement it tonight.
No, I mean, so we're not doing that now.
No, the dynamic shape variable does double duty. If length is none, then it's a singleton. Otherwise, it's a tuple. It's very strange.
Yeah.
But I just found an issue about this. Tuple variable is not entirely correct because they're not tuples; they're size objects. So like we should track this properly.
Well, what's the difference?
Size is like a subclass of tuple. It's mostly so you can like do is instance checks to see if something's a size or not. Yeah, I think literally the only reason we introduced the size object was because we had some constructors which also accepted lists to represent. It's the legacy constructor. We had lists. They accepted lists to like create tensors of that data, and then it was ambiguous whether or not you actually wanted to like create a tensor with the contents 1, 2 or a 1, 2 size tensor. So size disambiguates it. This is not a problem with the modern APIs, but like the legacy tensor constructors are like this.
It is. I guess for the record, it is a little kind of weird to me that we're returning shapes at all.
Okay. So I think we'll do Jason's refactor. So I will file an issue about this, and maybe I'll do it, or maybe someone else will do it. We'll see. Okay. Okay. See you, Horace. Thanks for joining the stream.
No problem.
And yeah, that's it. So 2 hours later, we know what the bug is. That's very exciting because you don't always figure out bugs like this. Or you have to give someone else, give it to someone else and they figure it out, and you're like, how do they figure it out? I don't know. But it's very nice that we caught this all on the stream. Thanks, Laksh. Thanks for coming by. I know it wasn't so easy to follow all the discussion here, but hopefully you did get something out of it. And thanks, everyone. I'll be posting this up on YouTube, and see you all next time. Cheers.